Good afternoon. Thank you for the invitation to present KVT Group. KVT Group is an Austrian-based engineering and technology company having a presence also here in Poland via Biprotech, our subsidiary company, and we are a family-owned company operating since more than 30 years in the industry, in the chemical and environmental protection sector. We are very active in Europe, and also we have a significant footprint in Asia, and we are trying to cover different aspects in the industry. On the left side you can see our main office where we execute most of our engineering projects in Austria, and on the right side you can see our R&D center where we are utilizing 2,000 square meters of infrastructure for process development and verifying and testing new applications in the technical field. On the left side you can see our presence here in Kraków in Biprotech, entity we acquired 1 year ago, and where we have a significant larger footprint now on the Polish market for executing projects. On the right side you can see a subsidiary called BDI, engaged in biodiesel and pre-treatment technologies for HVO and SAF production. We are also operating 2 production sites utilizing glycerin and glycerin derivatives in Germany and the Netherlands. Coming more into the topic of today's presentation, I would like to start introducing our R&D facility, because it is the backbone of our group and the backbone of developing new processes and technologies. Introducing just the infrastructure, we have a significant investment in analytical instruments where we can perform most of the tests required to develop our technologies. And we are especially proud to host 14 chemists to newly develop and verify new technologies, which means in the way that we are always starting in a lab in the milliliter scale to investigate an idea. Idea could be the utilization of a byproduct or a waste stream to solve the problem or to regenerate valuable resources out of these streams. And after the milliliter scale and liter scale, we are typically going into the pilot scale, also in our own R&D infrastructure, which means we can perform in a 50 to 100, 200 liter scale pilot tests. What is our main focus? Our main focus is in 2 aspects. One is the industrial environmental protection area, where we are looking actively for waste streams not being able to be treated with conventional technologies. And the other one is to utilize renewable feedstocks, biomass, byproducts for the production of bio-based chemicals. These feed streams could be vegetable oil, other waste oils, but also sugar, starch, or lignin-based and cellulose products. Showing some examples, we have started to be engaged in liquid extraction processes for recovering valuable raw materials and chemicals. We are working intensively on sulfuric acid recovery processes. We are dealing with solvolysis. Our current R&D topic is to work with used turbines from wind energy production to recover resin or fiber material. But we are also actively looking for the processing of biomass and recovery of, for example, furfural and acetic acid. Being more specific, I would like to introduce 2 closed-loop concepts we are applying. One is our so-called sulfuric acid technology, where we are working with sulfur-bearing off-gases, spent acids, or other waste streams containing H2S, CS2, or other. And we are looking actively to recover energy and sulfuric acid as a valuable product. These processes are mostly related to the metallurgical industry, but also to the refinery industry, for the viscose fiber industry, and also other industries like the power industry. Yeah, we have currently managed to set a new standard for SO2 emissions. We have worked according to European standards. Most of them for sulfuric acid plants apply an SO2 stack emission limit of 100 milligram per norm cubic meter, and we can apply lower than 15 milligram without an additional scrubber system or generating a waste stream, as we only produce weak acid which can afterwards be recycled. We have also applied our so-called Chlorox technology, dealing with chlorinated waste streams with the same purpose, recovering energy, but in this case hydrochloric acid as a byproduct, while cleaning emissions and getting rid of the waste stream. This has been applied close to all PVC or other related chlorine industry products, and is still an ongoing business field of KVT. I would like to point out in a small case study a new topic we have introduced. We are working since 10 years on this topic, but we would like to remind or explain our history in this development. We came across in our own development of the ECH process across a wastewater with high salt concentration. In the case of ECH, the concentration is around 19% sodium chloride. And we have realized that many other industries are also producing a wastewater with a high salt content where no standard treatment solution is available. We also have to admit and realize that water is a limited resource in many areas of the world, and the recovery and the purification must have highest priority. And applying closed loop concepts and also recovering resources from waste streams is a target. So what was the initial situation? We have seen in our technology for ECH, we are applying, or we are generating around 5 to 35 cubic meter of wastewater per hour with high salt content, and the TOC up to 8,000 ppm. This displays a significant challenge, and which led us to investigate in a modular plant system with the purpose of applying a closed loop concept. So typically epichlorohydrin or epoxy resin production is closely linked to chloralkali plants. In the chloralkali plant, chlorine and caustic soda is produced. Caustic soda is mainly used in the epichlorohydrin process for saponification, but firstly with the chlorine, glycerin is chlorinated with HCl gas to produce dichlorhydrin, which is afterwards used in the saponification, and a brine is generated. So sodium chloride with 19% weight is together with organic impurity generated. Similarly, in the epoxy resin process, also such a waste brine is produced. So our effort was made in that aspect, that we thought, okay, if we cannot develop a production process which leaves an environmental problem. So our first target was to purify the wastewater, but under the aspect, as we are close to a chloralkali plant, and for sure we don't want to discharge the sodium chloride content, our biggest aim is to recycle and purify this wastewater and recycle it to the chloralkali plant. Electrolyzer process has very strict requirements on organics, but also on heavy metals and other impurities. And therefore, we started with a development cycle, starting from the lab in the milliliter scale, then going to the small-scale pilot plant with 2 liters per hour, implementing a 100-liter pilot unit, and the 60 cubic meter industrial plant via a time span of around approximately 8 years, with many iteration between the different type and sizes of the plants going back and forth in the development, with the result that we now are specialized in the business level of waste, salt and brine treatment. And we are now having an infrastructure starting with tailor-made brine treatment solutions of 250 milliliter in a batch autoclave, and we are offering the possibility in a 2-liter proof of concept scale and a 100-liter proof of concept scale. Having solved the problem for ECH and epoxy resin, we are also looking into other waste streams coming from PO production, PC production, polyurethane production, and other like CMC. And we are still exploring and continuing to investigate new fields of brine treatment and respective applications, always with the targets to recover the salt for further utilization in the chlor-alkali plant. So, as a summary, our process has been proven to this, and applications in ECH and epoxy. And by the time we were able to implement 14 such units, either currently under operation or in the design stage, but what we would like to showcase is not that we are a successful company managing to get 14 contracts, but it should motivate to look into waste streams, which are on the first look very challenging, but on the other hand can be a business perspective for the producer of the wastewater and also for the company working in the technology field. So this being said, we can conclude that there is a solution for challenging wastewater like a brine, and this solution can also be economic feasible. At least for ECH and epoxy resin, we are knowing that we have high capex to implement the unit. We are OPEX neutral with the salt costs and the recovery, and especially with the recycling of the purified water and the CO2 emission reduction in not having the need for bringing fresh salt from a salt mine or from the sea to a chlor-alkali plant, because it is displayed in a 100% closed loop from the recovery of the purified salt. Yeah, to show that this has been or have been implemented, we would like to take you along our journey with a few impressions at the end of our presentation. The first unit we built is located in Germany. For an existing epoxy resin producer, we installed an ECH production unit and combined it with a brine treatment unit and the recycling to the chlor-alkali plant. We could scale up both the technologies to project in China where 10 times the ECH production is applied for 150,000 tons, but it also purifies 80 cubic meter of the wastewater, which is 100% feed stream of the sodium chloride plant. And we also have implemented for standalone epoxy resin production also in China for 65 cubic meter of wastewater. And currently we are working on a 100% closed loop project, which is about to be completed, where an existing chlor-alkali plant is revamped with a full epoxy resin production facility, starting from crude glycerin distillation as feedstock for epichlorohydrin production, coming from the epichlorohydrin production, receiving the main feedstock ECH for epoxy production, and the waste brine purification is the 100% feed for the chlor-alkali plant. Yeah, this is an example for a sulfuric acid, a large sulfuric acid plant close to a copper smelter for treatment of the off-gas and the recovery of sulfuric acid. At the end, I would like to thank you for your attention. I hope you could get a good insight to our group, and if you have further questions, please don't hesitate to contact Vladi Lewandowski, our Managing Director of Biprotec in Poland, or myself. Thank you very much for your attention.